Okay, so we finished going over the previous pages and the last video about position time graphs. And again, this information is the same information that we've been talking about. Just take it slow, take it piece by piece. Don't overwhelm yourself, okay? You've got to kind of take this slow and really think about it as you go through. So here I want to talk about position time graphs and talking about what the positive and negative direction means. And normally when I've done this in class before, I've done it with using people and students walking around the room, which since a couple things, we're not at the same point, as well as the fact that not everybody is doing the same thing at the same time. That makes this part really challenging. But I want to see if I can give you some of the same information so that you can tie some of this information into what is physically happening between positive and negative, because I think a lot of times people think of negative numbers as being like below less than 0, and that's not really the case here. So I want to try to talk about that a little bit, because I think this gives you a little bit of appreciation for what do these negative numbers really mean. So we're doing green, page 18. So if we're looking here, and I'm just looking at all the stuff in the positive direction for right now. So if you start with an X equaling or representing the reference point, because that's what we're going to call like our 0 point, our reference point. Remember back when we did distance and displacement, we always had to measure these things from a reference point. And you initially have an individual and they're stationary. So they're stationary now and they're at the reference point. It would mean that their DT graph would be a horizontal line on the x-axis. So you'd look at this, and I know it's hard to see here, but there really is a purple line here. If you have a second person and they're standing over here, they're in the positive direction. They're also stationary. Their DT graph is going to look like this because they're standing some distance away from the reference point, and it's also in the positive direction. So this is what it looks like, and they're staying right there. So that's what their DT graph looks like. Now, if we consider two individuals who are going to run at constant velocity, and they're going to head in the eastward direction, which we're taking as positive, one of them is going to start at the 0 reference point, and the other one's going to start at some place more positive than that, okay? So this first person's graph is going to start at 0, and they're going to run at a constant speed, so it's going to be a constant slope. So it's just going to be a straight line heading in the positive direction. And the person who starts a little bit of ways away from the reference point, they're going to be starting up here, and they're going to run in that direction. Okay, so these are straight lines with non-zero slopes. They're positive slopes here in this case because they're running east. And that's what the constant velocity is representing. So now if we're going to look at two individuals and they're going to be speeding up. One's going to start at the reference point and one is going to start a little ways away from the reference point in the positive direction. So if they're going to speed up, that's what these little lines are representing here. They're three all the same. And here they start slow, they get a little faster, and then they get even faster. So that's how they're representing that accelerating. So initially, they're going to start at the 0 point, and they're going to move a little bit in the first time interval, the next time interval a little bit more, the next time interval even more, the next time interval even more, and eventually, if they continue to speed up, they will end up with a vertical-like line. So this curve ends up having increasing magnitude of the tangent line, and it heads more towards this vertical. The person in red here, who starts a little ways away from the reference point, their curve looks very similar. It's just that it started at a different point. So they start up here, it's relatively flat, and then it gets more and more vertical as time goes on. Slowing down with these two people, they represent the slowing down here where the top line is longer, the middle line is shorter. There's a bottom little third line here that's really even hard to see on this scanned copy. And so they're slowing down as time goes on. But again, this person is at the reference point. So they start here, they're moving fairly fast, so they cover a large distance. Then they're moving not quite as fast, but they're still covering quite a distance in the next time interval. And eventually they're slowing and slowing and slowing until they're hardly moving at all, and they're essentially stationary at the end, okay? The similar curve for the person who starts to the positive direction of the reference point, they're starting up here and they're moving a lot and a little bit less, and then less and less until they're almost zero, okay? So they end up with a curve that has decreasing magnitude of the tangent line slope here. Okay, so this is what everything looks like in the positive direction. So let's take a look at the negative direction. So now in the negative direction, the position is now relative to the reference point, and they're essentially like to the left or west, depending on how you want to look at it. And I would recommend maybe doing these in different colors. If you still want to keep the guy who's at the reference point, I don't know that I'd want to keep him in purple because these guys are going to move in the negative direction. So I think having another color, if you're going to do this, is going to be helpful. So here they represent the guy who's stationary at the reference point in green, and you end up with a horizontal line. So he's at rest. And this person who is to the negative of the reference point, and they're at rest, they're not moving at all, and they've got a straight horizontal line, so they're stationary. And we're calling them at rest. For these that are constant velocity, again, the three lines that are similar in length here, these guys are going to run to the west. So the green one starting at the reference point, he's going to run at a constant velocity, and he's going to run in the westward direction. For the one who's starting a little ways away from the reference point in the negative direction, they're starting down here. Again, constant velocity, straight line, but that's not horizontal. So that's what constant velocity in the negative direction looks like, and that's what they're doing. For speeding up, we have them accelerating. So the top little line here is small, then it gets a little bigger, then it gets a little even larger. They're accelerating to the west. So it looks like this person is running in this direction. So they start out not moving a lot in the first time interval. They move a little more in the next time interval, and then they move more and more in each successive time interval. Eventually, if they continue going long enough and they speed up enough, they will end up with pretty much a vertical line. So they're heading towards a vertical line. Similarly, the person who's starting out farther negative from the reference point is running in the western direction or the negative direction. Their curve is similarly shaped, but initially they're starting out here a little bit farther down on the y-axis. So it's relatively horizontal initially, then it starts curving, and they end up covering more and more distance as time goes on, and it's going to have something that's close to a vertical line. Then finally, for slowing down, we have our three little lines. The top one is the longest, the middle one is kind of the mid distance, and this little one on the bottom is very short. So they're decelerating, but they're still traveling, and they're heading in the western direction. So the green person starts out at 0, and they're traveling pretty quickly. So that means they're traveling a longer distance at the beginning. And then as time goes on, they travel less distance, and they're eventually heading towards not traveling at all, because they're heading towards being at rest. So that means that they're heading towards getting a horizontal line. The person who's over here farther, starting at the negative position here, it just means that they're starting at a little different position on this y-axis, and they are having a very similar shaped curve. So they start out traveling a significant distance initially, then less of a distance and less until they're basically with a horizontal line. So if we put it all together, we end up with this information. So if you're not comfortable with the word tangent line, you don't really need to use that. I like the idea of speeding up and lines heading towards a vertical line, because many students in this sophomore class have not talked a lot about tangents and may not be very comfortable about it. And I like slowing down that they're heading towards a horizontal line, because if we recognize that a horizontal line means that they're not moving, slowing down, meaning that they're heading towards not moving, kind of makes sense. Okay, so I'm hoping that we've now looked at these distance time graphs and these velocity time graphs in a number of different ways to try to understand physically what's occurring, trying to understand how to describe the motion. So your follow-up work is 3 mop maps. And most students tell me these are the hardest ones so far. So take your time. Use all these resources. Don't sit there and say, I can't do it, and you're not using your resources. And don't rush through them, okay? Because they're going to ask you a lot of questions about, is this constant velocity, or is this object at rest and then speeding up? And you need to work very carefully and very thoroughly on these. Do them one at a time. If you do get stuck, I am happy to help you. That's what I'm here for, okay? So, but again, use all your resources. You have a lot of resources to help you with all of these, with our doodle note sheets, our summary sheets. But in addition, there are some resources on Physics Classroom that are very helpful. There's some information about discussing the meaning of shape and the meaning of slope. They have a few interactives. There are a couple videos. So if you really sit down and you're like, I'm really lost, and rewatching my videos isn't helping, or looking at this information isn't helping, go there, see if that can help you. So again, I'm going to recommend that you take your time going through these, okay? And please don't hesitate to ask me questions, send me screenshots. I'm happy to help you. But again, these will take you a little bit of time. You're not going to get these done in just 5 minutes each, okay? So take your time, good luck with these, and come to me with questions.